we going over the heterological paradox so much? We keep on hearing heterological and ontological, and we're probably, I think we're used to it by now, but we're probably associating with heterosexual and all of this stuff. It really has nothing to do with that. The reason that we're going over the heterological paradox is because a man named Grelling, it was originally called, and it is still called the Grelling paradox. It's probably on Wikipedia. I don't know. Check it out. Now, Wittgenstein was interested in this problem in his later revised philosophical investigations, whereby he rejected his previous Tractatus, Breakdown of the World according to atomism, logical atoms. He didn't exactly, he just thought he did. So, what I will go through at some point the axioms and the theorems and the properties and the connectives and so on, maybe. But the nice thing about the heterological paradox, and I'm going to have to use notes today, is it's such a peculiar paradox because it's so amenable to so many areas of everyday life, of perspective, and of the way you look at things. Yeah. At the same time, it's basically, why is it like that? This paradox it has the best overlay. It's the best overlaid logic of life. It's life and this paradox overlay each other more than any other logical system I've seen, because this isn't just a paradox, it's a system. And the overlap with real life is just so miraculous. So, without further ado, I would just say that Wittgenstein wrote in his philosophical investigations, he was very straightforward about it. He just said, why can't we have red of red, or we can, which is ontological, is equivalent to, not equal, but is equivalent to, same thing, basically. Red of green, or car of car is equivalent to car of dog. You know, predicating that way. It should be obvious that we can do that. To him, he was a genius. But he had a point. Because what is the difference, really? What is the difference? Well, it turns out that there is a difference, but when von Richt solved it, or his solution to it, was by introducing the Greek glyph, the epsilon Greek glyph, and substitutability. You can substitute one thing throughout a whole system, one symbol for another symbol throughout a whole system. And if you keep it consistent, then the results will be the same. The thing is, if you substitute this particular glyph throughout the whole system, or any glyph, it turns out that you reach the paradox itself, a demonstration of the paradox. Wittgenstein said, why can't we have P of P equals H of P? Well, we can, but we can do more than that. This particular glyph is illustrative of perspective itself, and so that's why we're going over this stuff, because it's such a wonderfully amenable logical system and paradox. You can come to a demonstration of it where it actually demonstrates that it is consistent and not contradictory, and that It is not paradoxical. Indeed, it is an aspect. And a true aspect. I'm not using an analogy to how we talked about aspect before, duck rabbit and stuff. No, it truly is a duck rabbit. A duck rabbit, not just an analog to it. It truly is, carries those very identical properties. I don't think we'll get that far today, so what else? Look, mathematical systems come and go. A computer program that works today may not work tomorrow, for whatever reasons. For whatever reason. The main reason is that that existential property that we were talking about that binds P and Q for eternity. When we can undermine it when we say for all x, q of x, therefore anything can be it, or there is a P such that not q of x. So you can undermine it that way. And so a computer program can fail because of the lack of that existential property. It's also a disjunction property. It's like me saying, it's like somebody asking me, do you think you'll be able to fix your carburetor? And I can say, I really don't know if I can do it. I mean, for all I know, a meteor will fall. And just before it's fixed, it will hit the car. Right? So, for all I know. Also, why do mathematical systems come and go while logic stays the same? Well, I'll tell you, it's a bit of a joke. But my mentor, he didn't make a joke of it, but why? Well, it's because they have to sharpen their pencils all the time, right? You can see it, they're sharpening their pencils all the time because mathematical systems, they come and go. And, the pens are always running out of ink, whereas the logician, he's dealing with things that are, you can mathematically render them in mathematical terms. But what it is, logicians use symbols, yeah. Okay, so you have a pyramid made up of a point here, and a point here. And it just means therefore. For me, that's egotistical. You make up all of these signs, you create a sort of esoteric language. And for a lot of, for one of Ayer's, Ayer was a great philosopher, students, I forget his name, but he was also very interested in the counterfactual conditional. And he completely did not use symbols. So it's completely amenable. Logic can be said in absolutely normal language. So that's why I don't need a blackboard behind me. Mathematics can't. So that's why they disappear all the time. You just erase them from the board. So now, but anyway, I did have to take notes today because I'm trying to hit a lot today. Let's go over another thing. We just went over why this particular system, this heterological system, is so interesting. Well, let's start with. How shall we start? Okay. Suppose, there's this thing called a universal Turing machine. It's a theoretical object, but Alan Turing invented it. He said that something is intelligent, and this is what AI people like. I like it too a little bit, but not so much. Because it's a philosophical matter, ultimately. He said, if a machine can answer your question just as well as a human being can, just as good as a human being can, then it's a universal Turing machine, meaning it has intelligence. Now, the earliest, it can't answer complex questions, of course. It can only answer questions for which it is programmed. As we develop algorithms and such, they can answer more things, but it will never be able to answer everything. And that has to do with a lot of other things, which maybe we can go into later. But anyway, so, I'm a professor. I have this cup here, okay? Okay. Now, one of the things about a universal Turing machine is that you can take the machine itself, and if you give it in order, it's the same thing as asking it a question. Okay? So I'm going to say, I'm going to put this thing here, I have a universal Turing machine. And I say, don't move. Do you see it moving? Let me put it here if you can't see it. Whatever. Don't move, with a little help from your right and left hand. Do you see it moving? No, it's shaking a little bit. Anyway, well, now there's this cocky physics student who's auditing this particular philosophy course, and he comes out and he puts his hand out and he says loudly to the professor, "You forgot about relative motion." And that's a fact. I think you can see yourselves what I'm getting at. Perspective. There's another very interesting thing that I learned from my university studies. I'm trying to get all this knowledge out of my head because otherwise it will die with me. The person from whom I learned it, he was the last of his kind who carried this knowledge, and it's very important that it get out. Everybody else has developed it into fancy mathematical systems that will kill it. Like every good and great idea or set of ideas, how do they get killed? When people overthink them. In fact, they don't overthink them, they ruminate. They think, well, okay, I have this. They over-formalize the thing, and then the thing doesn't make sense anymore. It becomes that computer program that fails the next day. Because in formalizing it, they will have made a mistake. It's the law of diminishing returns, okay? The more you formalize something. Okay, a system. So, now there's something else interesting. This is a bit of a strange one, but I don't know if you can see me here. That's okay. I'll do it like this. How am I going to do this? I'll go way back like this and hope that you can see me. Anyway, there's something about the salute that's interesting. It's related to authority. It's called the Roman salute, a particular ideology that killed millions, tens of millions of people used it during the Second World War. That's why Theodore Roosevelt. So it's like this, right? Right? Okay? Now that's the Roman salute. Our friend Hitler wrote about it with frightening with frightening, he wrote a little essay about it with frightening accuracy. So that's actually why Roosevelt changed it. We didn't do this anymore. We put our right hands over our hearts instead. So everything is, not everything is related, but something, there are things that do come out. Now, this is how it's related with the Roman salute, okay? Let's take the Nazis, unfortunately, okay? Because they did it, they did this salute even with more physical and emotional and psychological intensity, and that enhanced the effect much more. The effect I'm going to talk about. So what you do, you put your arm up like this, right? At about eye level. You can put it up at eye level or whatever, but it has to be at about eye level, okay? So your body is essentially inert, yeah? Okay? You have the movement. It's not inert. You're holding your arm there. Now, nothing, it's not causing anything else to happen in your body that's significant except the muscles to hold it up. But when you do this, what happens? Watch my anus. Look at my sphincter. My sphincter tightens, okay? So you go like this, my sphincter doesn't tighten, okay? Then you go like this, so you go like this. So, well, I'm not going to say what, so word, stop. Watch my anus. That's what my professor said. We all thought it was very funny, but we knew that he had such a depth of knowledge that he was trying to get across to us something. And the fact is, acts, he used to say act when he wanted to emphasize this. So when you're giving the ultimate submission to authority, you're going to have something happen in your anus if you're going to express it. If you're going to express it in a salute, which culturally is the way that we give our ultimate authority to a dictator. So that has to do with authority. We're submitting, but he also does it. Okay, so he has authority over us. This all relates to the symbolic challenge. You're challenged. He's challenging you. You're accepting the challenge. So let's get back to the challenge. This is all. Now we'll go, because that will take us back into the heterological paradox, and thereby into aspect. Now you remember in a previous lecture, I think it was the first one. Okay, we had the duck-rabbit, right? We're going to the old duck-rabbit thing. It was very important for Wittgenstein, and it turned out to be very important for philosophy in general. Now, of course, my example was, okay, I go to the blackboard, I draw just a normal duck or a rabbit, however I'm visualizing it at the time. You remember how it switches perception, duck rabbit, duck rabbit, duck rabbit, and you're automatically processing it, right? And you will remember also how rabbits are herdish, and if we put herd next to it, you would associate when you're seeing the rabbit, if you were asked to, you would, by the teacher, you would say, which one is herd? You'd think, and you'd say, well, not ducks. Well, by apophatic reasoning, I mean by negation, that means the rabbit. And indeed they are herdish, as we discussed before. They're in that category of mammalian land animals that walk. Okay. If you go home and your mother draws this thing there and she writes herd next to it, or no, that's not fair to mom. Maybe she's a philosophy professor. Let's say your little sister, she draws this for you. Hopefully she's not precocious. Let's say that somebody who is just really, for some reason, bonkers on that particular day, and it hasn't enlightened them, it just makes them happy, right? So they draw this thing, and then they write herd next to it, okay? Very hypothetical, but what if, okay? You would just say, oh, cool. Now, actually, they might know why they're doing it. You might not know that they know why they're doing it. And they might be aware of that. That might be the trick. Still, now, we go to Dr. Seuss. This little boy was always looking for ways that he could make himself better, improve how he does things by imagining that he can use mechanical things or different kinds of hats that will enhance his abilities. So, he says, I would like to have a whale's hole. Why? Because I could play in the summer and never feel the heat, right? Okay, that's from Dr. Seuss. Okay, and what happens? What happens when he goes home? He says, but my mother would not like it. I know just what she would say. Not in the house. You shut that off and take that spout off of your head. That's authority. Now, that is not the same authority that you take, that you vest in me when you do that, or when you are recognizing these things. And it's not the same authority when you have that bonkers uncle that particular day, and you don't know if he knows, if he's got this stealth scheme for you, or if he really is bonkers that particular day. So those are two aspects too. That's why aspect is so